So far, we've been using a lot of angles called degrees. And before we continue, I'd like to introduce a new way of describing angles, or rather, a better way. It's called radians. And a good way to understand radians is if I take a radius of a circle, no matter what length, and I put it on the circumference, wrap it around there, the angle that is formed is called 1 radian. You may ask, why do we need 1 radian? Well, we'll see why. It's a more natural thing to use compared to 360 degrees for angles and describing circles. In fact, something funny happens when we keep on wrapping that radius around the circle. We wrap it once, twice, 3 times, and so on, up to 6, and just a little bit more, up to 6.283 radians, or 6.283 times of wrapping that radius around the circle. We'll find that it makes a complete revolution. And if we want to be really precise, it actually takes 2 pi exact wrappings around the circle for the radius to completely become the length of the circumference. And somehow this isn't surprising that we see pi come out in this way, because pi is just simply the ratio of the circle's circumference to its diameter. In fact, this is true for any size circle, because as the size of the circle increases, the radius also increases to keep up with it. And so every circle has 2 pi radians of angles around it. So no formal definitions yet, but the reason why we want radians is because it's more natural. It's built into the circle. It's in the definition of the radius of the circle, whereas degrees, when kind of a randomly chosen number because it's very divisible. So we can see that the radian is actually the ratio of its arc length over the radius of the circle. And you can see that with a simple example where we can take the arc length being a radius, we wrap 1 radius length around the circle. If we divide that by a radius, it's the same length, then we get 1 radian. If we wrap 2 radius around the circle and divide that by a radius, we get 2 radians. So that's what we saw. Also note that the circumference is 2 pi r. And if we go around a full circle, then the radians is the arc length of the full circle divided by r. And an arc length of a full circle is the circumference. So we take 2 pi r divided by r, and we get 2 pi radians in a full circle. Interesting. So we can say that 2 pi radians is somewhat equivalent to 360 degrees, both in their own units, both in their own worlds, one in the world of radians and one in the world of degrees. And if we simplify this, we'll get 1 radian is actually equal to 180 degrees over pi, and 1 degree is a pi radians over 180 degrees. However, it will be simpler if we memorize this single line. Pi radians equals to 180 degrees. This would be much more helpful for your studies and during exams. Now for our first exercise, which is to convert pi over 6 radians into degrees. Remembering that pi radians is equal to 180 degrees, we can then get 1 radian is equal to 180 degrees over pi. And so pi over 6 radians is pi over 6 times 1 radian, which is 180 degrees over pi, and we get 30 degrees. Just to make sure that our answer makes sense, if we represent the circle in the terms of radians and describe it using radians, where a complete revolution is from 0 to 2 pi radians, then we can see that at pi over 6 radians, here, it's actually about 30 degrees, and it is 30 degrees. So our intuition is right here. Let's move on to another example, converting 5 pi over 4 radians into degrees. So remember that pi radians is 180 degrees. And so 1 radian is 180 degrees divided by pi. So to find 5 pi over 4 radians, we multiply that by 180 degrees over pi radian. And so we get 225 degrees for our final answer. Here is some extra practice for the reverse, converting degrees into radians. Pause to work this out for yourself. Here we're going to see why we really need radians. We're going to build an intuition for why radians is a much better way of expressing angles in circles. And one way that we can do this is we look at the formula that we discovered earlier in this video for arc length in the circle. This is related to x degrees over 360 degrees times 2 pi r. And this was the ratio relationship between the degrees and the length of the arc of the circle. So if we use our new formula, changing pi radians equals to 180 degrees and substituting that into our equation, I'm not going to go into the derivation, but here is actually what we can get. A new definition for the arc length of the circle, which is the arc length S is equal now to the radius of the circle times theta radians, the angle of that arc. And then if we do the same for the area formula for the sector, which was related with the ratio of the degrees of that sector and the area of that sector, then if we substitute in the formula that we have, the relationship between radians and degrees, pi radians equals to 180 degrees, we put that into this area formula, replace x degrees into radians, we get a new definition of the area expressed in terms of radians, which is the area of the sector is now half times the radius squared of the circle times theta radians, where theta radians is the angle of the sector. I didn't do anything fancy. I just simply subbed in the definition of pi radians is equal to 180 degrees. And if you want, you can try and work that out, but here's what we get. Let's try out our newfound knowledge of using the radians format of our equations. Starting with this question, which asks us to find the area of the sector. So the area of the sector in the radians format is half radius squared theta. We can simply sub in the values, like so. And we easily get the answer. So here's a quick summary on why we decided to use radians instead of degrees to describe the circle. Because radians firstly tie directly to the circle's geometry, and they're a lot more natural and more intuitive than actually degrees, which were chosen arbitrarily. They were chosen because 360 was a nice number to work with in the past. Secondly, formulas become a lot simpler and cleaner, as we just saw. For our arc length and area formulas, they became a lot more simpler to understand once we use radians. And lastly, they're extremely useful for advanced mathematics. So when we use radians in things like physics and calculus in your later years when learning maths, you'll find that using radians results in a lot more simplified and easier way to describe a lot of equations in these fields.
Smash your maths exams. Download Learn Maths Today for real exam questions and achieve top marks.